So, today we're going to dive into 3 substances that can radically change human consciousness. But we're not going to focus on where they come from or whether they're legal. No, we're going straight to the source. We're going to look at what's actually happening on a chemical level inside your brain when these things take effect. Here's the game plan. First, we're going to cover one fundamental rule for how your brain deals with any chemical. Then, we'll take that idea and apply it to 3 very different case studies: kratom, DXM, and salvia. And finally, we'll tie it all together and see what they all have in common.
Okay, so to really get a handle on any of this, there's one core idea we have to nail down first. Your brain is a biological machine. It doesn't have opinions. It doesn't care if a substance grew on a plant or was made in a lab. It only recognizes one thing: the specific shape of a molecule and whether that shape can fit into its receptors. It's really just like a key fitting into a lock.
All right, let's see how this works in the real world with our first case study. This is a plant from South Asia called kratom.
So what exactly is kratom? Well, it's a tropical leaf, and its active chemicals have a very specific shape. It turns out that shape is just right to fit into the brain's opioid receptors. Yep, the exact same ones that are affected by morphine. But, and this is a huge but, the way they bind is a little different, and that difference is everything. It's what creates a totally unique profile of effects. And this is where kratom gets really interesting. Its effects are like a tale of 2 different drugs, all depending on the dose. In smaller amounts, it actually acts as a stimulant. You get more focus, more energy. But take a higher dose and the experience completely flips. It becomes a sedative, bringing on this deep relaxation and a feeling of warmth and comfort.
Now, because it's hitting those same opioid receptors, kratom carries some very similar risks. Your brain starts to adapt to its presence, which can lead to both physical and psychological addiction. Tolerance can build up fast, meaning you need more and more to get the same feeling. And stopping daily use can trigger withdrawal symptoms, which, while maybe not as severe as heroin, are still really tough to get through.
All right, for our next case study, we're actually heading to the pharmacy to look at a compound you can find in almost any cough medicine: dextromethorphan, or DXM for short.
You know, this is a fantastic example of how a chemical's purpose can completely change based on how much you take. At its heart, DXM is a dissociative. What that means is its main psychoactive effect is creating a powerful sense of detachment, a disconnect between the mind, the body, and the world around you.
So, just to give you some scale here, a normal medical dose to stop a cough is tiny. We're talking somewhere between 15 and 30 milligrams. At that level, it just does its job. No major psychoactive effects.
But a recreational dose? That can be anywhere from 10 to 50 times higher. It's a huge leap, and it perfectly illustrates how the same exact chemical can produce wildly different outcomes, based entirely on the quantity you consume.
So what does that feel like? Well, the experience tends to unfold in a few distinct stages. It usually starts with the body feeling kind of heavy and far away. Lower recreational doses might lead to a dreamy, floating state. But at those really high doses, you can get full dissociation, where a person's sense of self might feel completely untethered from their physical body.
And we have to be clear, the risks here are really serious. Tolerance builds fast, which can push people to take higher and higher doses. There's often a pretty brutal chemical hangover. And heavy, long-term use has been linked to severe physical harm, including liver damage and a terrifying form of brain deterioration.
Okay, for our last case study, we're looking at something that is truly in a class of its own: salvia divinorum.
What makes salvia so different is its chemistry. See, most classic psychedelics like LSD or psilocybin, they go after your serotonin receptors. Salvia doesn't. It targets a totally different system, the brain's kappa opioid receptors. Hitting this alternate chemical pathway produces an experience that is profoundly strange and almost always described as bizarre and deeply uncomfortable.
Trying to explain what the experience is like is, well, it's almost impossible. But this quote gets pretty close to the core of what people report. A total breakdown of the self, where you might actually lose your sense of being human and believe you've turned into a chair or a wall.
And the whole thing is over in a flash, but it's an incredibly intense flash. The effects hit almost instantly. We're talking seconds. Reality is just replaced. The peak experience only lasts for a few minutes, but it can feel like a lifetime. And then, just as suddenly, it's over, and normal consciousness has to sort of piece itself back together, leaving the person totally bewildered.
But maybe the most telling thing about salvia is what people say afterwards. Unlike a lot of other substances, the consensus here is pretty clear. There's no euphoria, there's no fun, and there are no deep insights. The main takeaway for most people is just overwhelming confusion and a very strong feeling that they never want to do it again.
Okay, so we've looked at 3 wildly different substances, right? A plant that acts like an opioid, a cough medicine that detaches you from your body, and an herb that completely rewrites reality for a few minutes. What's the thread that ties all of this together?
It really pushes us to ask a pretty basic question about how we work biologically. Does our brain care where a substance came from? Does it care if it's legal or what story we tell about it?
And the answer from a purely biological standpoint is no. It doesn't care at all. Your brain only responds to one thing, the chemical structure of a molecule, and how that key fits into its lock. Understanding that specific mechanism of action is the only real way to understand a substance's effect, the experience it can create, and the risks it carries. In the end, it all just comes down to chemistry.